A headline has been making the rounds. A lightweight 7 billion parameter open source model outperformed OpenAI's GPT-4o by nearly 42 points. That number comes from a specific benchmark called ALFWorld. ALFWorld is an agentic testing environment where AI models must navigate simulated text-based worlds to complete multi-step tasks, rather than simply answering open domain trivia. But reading that top-line number out of context creates an illusion. The base model here isn't spontaneously generating frontier-level reasoning on its own. The performance gap is the result of a highly structured three-part orchestration pipeline wrapped around the model. It extracts lessons from past actions, organizes them into a searchable library, and continuously updates them during training. The researchers used Qwen 2.5 Instruct as their base agent. Sitting directly above it is a highly capable teacher model, OpenAI's O3, which acts as the system's supervisor. Operating a 7 billion parameter model at this level requires a superior architecture for memory storage and retrieval, rather than a breakthrough in base model intelligence. When most developers build agents, they use an approach called episodic memory. This means every time the agent attempts a task, it writes its entire raw interaction history into a log file to read later. Those logs are incredibly messy. They contain every false start, every redundant search, and every hallucination. When you feed that unedited text back into an agent's context window, the working memory it uses to process prompts, the relevant information is buried under a mountain of noise. You could fix this through token compression, truncating logs to save space. But blindly cutting a raw trajectory deletes the context needed to understand why an action succeeded. Conversely, reading full failure logs confuses the model, making it repeat the exact same errors. If we want autonomous agents to operate reliably over long periods, the standard practice of dumping raw log files into the prompt has to stop. The SkillRL pipeline solves the memory bloat problem by placing the OpenAI O3 teacher model directly in the logging path to act as an experience filter. When the base agent completes a task successfully, the pipeline doesn't save the transcript. The teacher model reads the transcript, identifies the strategic decisions that worked, and writes them down. It compresses a long sequence of successful actions into a highly dense, reusable heuristic, a rule that the agent can apply to similar situations later. However, the critical design choice in this architecture is how it processes failure. Under this system, storing the complete trajectory of a failed attempt is strictly prohibited. Instead of a log, the teacher model is prompted to author a concise, counterfactual lesson, explaining exactly what went wrong. This extraction process requires three specific inputs. First, the teacher isolates the precise step where the task derailed. Second, it identifies the flawed logic or incorrect assumption that prompted that fatal action. Finally, it generates a clear preventative rule designed to stop the agent from making that specific assumption ever again. The pipeline takes thousands of sprawling, chaotic mistakes and converts them into structured, actionable directives. Every failure is instantly translated into a highly refined training signal authored by a frontier model. The 7 billion parameter agent achieves an 89.9% success rate on ALFWorld because it is being spoon-fed synthesized flawless reasoning from a much larger model, rather than trying to deduce those lessons itself. All of these distilled lessons are stored in a centralized database called the SkillBank. The SkillBank is formatted as a JSON file, a standard text-based structure used to organize code data, and it is divided into a strict hierarchy. The top tier consists of general skills. These are environment-wide heuristics, like always verify evidence before answering, and they are injected into the agent's prompt on every single run. The second tier contains task-specific skills. These are hyper-focused rules that the system retrieves dynamically by matching keywords in the current task description to categories in the database. For even tighter precision, the system uses an embedding retrieval mode. It calculates cosine similarity, a mathematical metric that measures how closely related two pieces of text are, to inject only the absolute most relevant skills for the job. By injecting only the necessary abstractions instead of full historical logs, this targeted retrieval method reduces the number of tokens sent to the model by a factor of 10 to 20.
The SkillBank proves that a highly compressed abstraction layer is more effective than standard retrieval augmented generation. Retrieval augmented generation, or RAG, is the typical process of fetching external data to ground an AI's response. But running it over raw event logs simply feeds the model way too much chaotic, distracting noise. The third mechanism is recursive coevolution, which occurs during the agent's GRPO training. GRPO stands for Group Relative Policy Optimization, an algorithm that trains models by scoring multiple possible outputs against each other. The system continuously monitors success rates across task categories. If a specific category drops below a threshold, it triggers a memory mutation. Looking at the open-source SkillBank class, the retrieve method isolates critical lessons. Then, format for prompt injects them into working memory, categorized as general principles and mistakes to avoid. To prove the agent is actually relying on this injected knowledge, the developers built a strict testing loop. The train A/B test function splits the training path, forcing the model to attempt tasks with skills loaded and without them. The algorithm compares outcomes, applying a penalty if the agent ignores injected skills. The agent isn't querying a static library. Its memory structure dynamically mutates during training, automatically generating new rules to patch its own behavioral blind spots. To confirm exactly which of these mechanisms is driving that massive 41-point performance gap, we have to look at the paper's ablation studies. An ablation study is an experiment where researchers remove individual components of an AI system to see how much the performance drops. In the first test, researchers stripped away the hierarchical structure entirely, leaving only a flat, unorganized list of task skills. Without the strict categorization prioritizing general roles, the model's success rate on the ALFWorld benchmark fell by 13.1%. They observed a similarly steep double-digit collapse when testing the model on WebShop, an entirely different e-commerce navigation environment. The second test removed the distilled skills entirely and forced the agent to rely on standard, raw trajectory logs. Performance degraded by a massive 25%. This data confirms the central rule of the architecture. Abstraction outperforms rote memorization. However, this architecture carries a severe technical vulnerability known as entity leakage. The very act of compressing a messy interaction into a clean general principle requires the teacher model to strip away the exact context of the situation. By summarizing the event, it destroys highly specific text strings. In a corporate environment, those exact strings are the entire point of the task. If an agent is processing IT tickets, it needs the exact tracking URL, the specific hardware SKU, and the precise case ID. Because the abstraction filter throws those exact details away, the agent will frequently generate plausible but entirely incorrect substitutions. It hallucinates data because its memory system was designed to forget the specifics. Engineers can mitigate this by manually adding strict constraints to the extraction pipeline. By forcing a must-retain entities field into the JSON schema, the teacher model is ordered to preserve exact data points alongside the broad heuristics. Warning tone: architectural abstraction creates incredible computational efficiency, but in deterministic enterprise applications, that same efficiency will introduce fatal hallucination risks if you don't explicitly protect the underlying data. SkillRL operates as an offline training pipeline, meaning its memory updates happen in batches. This sits in contrast to emerging frameworks like OpenClaw RL, which perform continuous online reinforcement learning, updating the agent's policy live after every single interaction. But while live updating is the frontier, the hierarchical SkillBank offers an architecture that developers can ship into production today, particularly for agents operating in stable, repetitive domains like customer support. The 41.9-point advantage over GPT-4o proves that how an agent organizes its past is far more important than the raw size of its neural network. Structured, abstracted experience consistently beats raw memory retrieval. Actual gains in agentic reliability come from treating failures as highly compressible data, not as discarded waste to be logged and forgotten. Overcoming standard memory limitations requires every error to be processed as a structural asset.